What if we're not alone in the universe? Picture this: a radio telescope in Ohio picks up a signal so strange, so startlingly powerful, that the astronomer who discovers it scrawls, "Wow." In the margin of the printout, decades later, we still have no explanation for that brief, electrifying burst from deep space. It's moments like these that remind us the question of alien life isn't just science fiction. It's a mystery woven into the very fabric of our history, our science, and our imagination. From ancient cave paintings depicting strange beings to modern-day pilots tracking unidentified objects that defy physics, humanity has always looked to the stars and wondered who else might be out there. This video is a journey into the unknown, where we'll unravel 30 of the most compelling questions about extraterrestrial life. What would alien civilizations look like? Could they already be watching us? And if they exist, why haven't we found them yet? These aren't just hypotheticals. They're puzzles that scientists grapple with every day, using cutting-edge technology and bold theories to search for answers. Think about it. In a universe with billions of galaxies, each containing billions of stars, the odds suggest we shouldn't be the only ones here, yet the silence is deafening. That contradiction alone between the vastness of space and the absence of proof is enough to send shivers down your spine. So buckle up. We're diving into the evidence, the myths, and the mind-bending possibilities that keep astronomers, philosophers, and even governments up at night. Along the way, you'll hear stories that sound like they're ripped from a thriller, government documents declassified after decades, strange signals that vanish before we can decode them, and encounters that defy logic. Whether you're a skeptic or a believer, one thing's certain: by the end of this exploration, you'll never look at the night sky the same way again, because out there in the infinite dark, the truth is waiting. And it's far stranger than we've ever imagined. The universe is unimaginably vast, so vast that our minds struggle to grasp it. With hundreds of billions of galaxies, each filled with hundreds of billions of stars, and countless planets orbiting those stars, the numbers alone make it seem almost impossible that Earth is the only place where life exists. So where is everybody? That's the haunting question at the heart of the Fermi Paradox. Named after physicist Enrico Fermi, who famously posed it during a casual lunchtime conversation. This paradox highlights the glaring contradiction between the high probability of extraterrestrial civilizations and the complete lack of evidence for them. To understand just how strange this silence is, let's break down the Drake equation, a way to estimate the number of intelligent civilizations in our galaxy. It considers factors like the rate of star formation, the fraction of stars with planets, how many of those planets could support life, and the likelihood that life evolves into intelligent, communicative beings. Even using conservative estimates, the equation suggests there should be at least some detectable civilizations out there. Yet, our radio telescopes and space probes have found nothing but static. But the search isn't hopeless. In recent years, astronomers have discovered thousands of exoplanets, worlds orbiting distant stars, with many sitting in what we call the habitable zone. This is the sweet spot where temperatures could allow liquid water, a key ingredient for life as we know it. Some of these planets, like those in the TRAPPIST-1 system or the intriguing Kepler 186f, even resemble Earth in size and composition. So if the ingredients for life are scattered across the cosmos, why haven't we stumbled upon a single whisper of alien intelligence? Possible answers range from the unsettling to the awe-inspiring. Maybe civilizations wipe themselves out before they can reach the stars. Perhaps they're so advanced that we're like ants unaware of a passing airplane. Or could it be that space is just too vast, that signals fade into the void before they ever reach us? Whatever the reason, the silence isn't just a scientific puzzle. It's a mirror held up to humanity, forcing us to ask, is our fate to be alone in the dark, or are we simply not listening hard enough? if life exists beyond Earth, would we even recognize it? Science fiction often paints aliens as humanoid, 2 arms, 2 legs, a face, but the reality could be far stranger. To understand what alien life might look like, we need to start with the basics, the chemistry of life as we know it. On Earth, every organism shares a common blueprint built around carbon. This versatile element forms the backbone of proteins, DNA, and the complex molecules essential for life. But what if carbon isn't the only option? Some scientists speculate that silicon could play a similar role on other worlds. Like carbon, silicon can form long chains of molecules, and in extreme environments, think scorching volcanic vents or the crushing depths of alien oceans, it might just work. That brings us to extremophiles, Earth's toughest life forms. These microbes thrive in places once thought uninhabitable: acidic lakes, radioactive waste, even the vacuum of space. If life can cling to existence here under such brutal conditions, why couldn't it adapt to the icy geysers of Europa or the methane rivers of Titan? The discovery of extremophiles has blown open the doors of possibility, suggesting life might flourish in environments we'd consider hellish. Then there's the mind-bending idea of a shadow biosphere, a hidden layer of life on Earth so alien in its biology that we've overlooked it entirely. Imagine organisms with a completely different genetic code, or microbes that don't rely on water but instead use ammonia or liquid methane. If such life exists right under our noses, it rewrites the rules for what we should be searching for on other planets. Science fiction, of course, has already run wild with these concepts, from the crystalline entities of Star Trek to the ammonia-breathing creatures of Arthur C. Clarke's novels, storytellers have imagined life forms that defy our earthly biases. But here's the twist: some of these fictional creations aren't as far-fetched as they seem. When scientists design hypothetical alien ecosystems, they often arrive at eerily similar visions. So the next time you gaze at the stars, remember, the universe's palette for life is unimaginably broad. We might one day meet beings shaped by forces we can't comprehend: gelatinous blobs floating in hydrocarbon seas, or electromagnetic entities woven from pure energy. The only limit is the cosmos itself, and that's what makes the search so thrilling. Could aliens be walking among us right now? It sounds like the plot of a sci-fi movie, but the idea isn't as far-fetched as you might think. For centuries, cultures around the world have recorded encounters with beings from the sky, from the Vimanas of ancient Hindu texts to the mysterious sky people described by indigenous tribes. Even Renaissance paintings depict strange, disc-shaped objects hovering in the background. Are these just myths and misinterpretations, or could they be early evidence of extraterrestrial visitors? Fast forward to the modern era, and the sightings haven't stopped. In fact, they've escalated. The US government's recent declassification of military footage showing unidentified aerial phenomena, or UAP, has reignited the debate. These objects move in ways that defy our understanding of physics. Sudden 90-degree turns, hypersonic speeds without sonic booms, and the ability to hover effortlessly. Navy pilots, trained observers with decades of experience, describe encounters that leave them baffled. One infamous incident, the Nimitz encounter in 2004, involved a tic-tac-shaped object that outmaneuvered advanced fighter jets. Skeptics argue these could be secret military projects, but if that's the case, the technology is decades ahead of anything publicly acknowledged. Then there's the theory of ancient astronauts popularized by figures like Erich von Däniken, which suggests that extraterrestrials visited Earth long ago, influencing human civilization. Proponents point to architectural marvels like the pyramids of Egypt or the stone heads of Easter Island, asking how ancient builders achieved such precision without advanced tools. Could these sites be evidence of alien intervention? Or are we underestimating the ingenuity of our ancestors? the debate rages on, with scientists often dismissing the claims as pseudoscience while alternative researchers argue mainstream archaeology ignores key anomalies. The truth is, we're left with more questions than answers. If aliens are here, why haven't they made formal contact? Are they observing us like a cosmic experiment? Or is their presence so different from our expectations that we fail to recognize it? Some theorists propose that extraterrestrials might exist in dimensions beyond our perception, or that they've mastered camouflage technologies rendering them invisible. Others wonder if microbial alien life could already be hiding in Earth's oceans or deep underground, completely unnoticed. One thing's certain: the line between conspiracy and credible investigation is blurrier than ever. With governments taking UAPs seriously and astronomers scanning the cosmos for biosignatures, we might be on the verge of a revelation that changes everything. Whether the truth involves visitors from another star system or breakthroughs in human technology, the mystery itself proves one undeniable fact: we're desperate to know we're not alone. Imagine trying to have a conversation with someone when every sentence you speak takes years, even decades, to reach them. Now picture that gap stretching across light years, with languages no human has ever heard and concepts that might not even translate across species. That's the monumental challenge of communicating with extraterrestrial intelligence. The very idea raises questions we've barely begun to answer. Would they recognize sound waves or radio signals as communication at all? Could they perceive time and space the way we do? Projects like SETI, the search for extraterrestrial intelligence, have spent decades scanning the cosmos for deliberate signals, listening for patterns in the cosmic static that might betray an alien hand. But listening is only half the battle. METI, or messaging extraterrestrial intelligence, takes the opposite approach, actively broadcasting messages into space like cosmic postcards. The most famous of these is the Arecibo message, beamed toward a star cluster 25,000 light-years away in 1974. Encoded in binary, it contained basic mathematical concepts, human DNA structure, and a crude stick figure of a person. A brilliant idea, or, as critics argue, a potentially dangerous one. What if we're announcing our presence to a civilization with less than friendly intentions? Then there's the problem of universality. Mathematicians suggest numbers could serve as a cosmic lingua franca, since the laws of physics should hold true anywhere in the universe. A hydrogen atom here vibrates at the same frequency as one in a galaxy far away. That's why the Arecibo message began with counting ones and zeros, primes, the building blocks any technological society might recognize. But what if aliens don't see in binary? What if their cognition is so alien that our concept of counting is meaningless to them? Some scientists speculate that advanced civilizations might communicate through quantum entanglement, instantaneous links between particles across vast distances, something that would make our radio waves look like cave paintings. Perhaps the most sobering hurdle is time. Even if we detect a signal from a relatively nearby star, say 100 light-years away, by the time we reply, 2 centuries will have passed on Earth. Civilizations could rise and fall in that silence. It forces us to ask, is interstellar dialogue even possible, or are we destined to shout into the void, hoping someone someday might understand? Yet the attempt itself reveals something profound. Every message we send carries not just information, but a snapshot of who we are. Whether it's the golden record aboard the Voyager probes filled with whale songs and Bach, or modern attempts to encode entire Wikipedia pages in laser pulses, we're not just trying to talk to aliens. We're leaving proof that we were here, that we looked up, and that we reached out. And if nothing else, that act of cosmic vulnerability might be the most human thing of all. What if our first contact with an alien civilization isn't a handshake from the stars, but a declaration of war? Stephen Hawking famously warned against actively reaching out to extraterrestrials, comparing it to Native Americans encountering Columbus. If aliens visit us, he said, the outcome might be much the same as when Europeans landed in America. It's a chilling thought. Could the universe be less like a welcoming community and more like a dark forest where every civilization hides, afraid to reveal itself? This grim idea, known as the dark forest hypothesis, suggests that advanced species might see competition as inevitable and preemptive strikes as survival. Science fiction has played out these nightmares for decades. In H.G. Wells' War of the Worlds, Martians invade not out of malice but sheer necessity, their dying planet forcing them to consume ours. Independence Day imagines aliens as galactic locusts stripping worlds of resources. Even Arrival, a story about peaceful contact, hinges on the terrifying uncertainty of whether the visitors' motives are benevolent. These stories tap into a primal fear that in the vastness of space, resources are finite and empathy might not cross the interstellar divide. But how much of this is grounded in reality? Scientists are divided. Some argue that any civilization capable of interstellar travel would have moved beyond aggression, having solved energy crises or developed cooperative societies. Others counter with a simple, unsettling truth: evolution rewards survival, not morality. On Earth, dominant species often displace or exterminate rivals. Why wouldn't the same apply on a cosmic scale? The universe is old, older than we can comprehend. If hostile civilizations exist, they've had billions of years to perfect their tactics. This debate isn't just philosophical, it's shaping real-world decisions. Meta-initiatives like beaming messages toward nearby stars have faced backlash from researchers who view them as reckless. The late physicist David Brin called it shouting in a jungle before we know if there are tigers. Yet others argue silence is just as dangerous. If we stop listening, we might miss a warning or a plea for help. Ethically, the dilemma cuts deep. Is it fair for one generation to risk Earth's future by calling out to the unknown? Or is isolation itself a form of cosmic cowardice? The answers might lie in our own history. Humanity's brightest moments, like the Voyager golden records, weren't born from fear but from hope. Maybe that's the only way to navigate the dark forest, not by hiding, but by daring to believe the universe isn't as cruel as we fear. After all, the scariest possibility isn't that aliens are hostile, it's that we're truly alone, with nothing but our own reflection in the void. Long before radio telescopes and space probes, ancient civilizations left behind clues that some believe point to extraterrestrial visitors. Take the Nazca lines in Peru, enormous geoglyphs carved into the desert floor, some stretching over 900 feet. From the ground, they look like simple grooves in the earth, but from above, they form intricate shapes: a hummingbird, a spider, even what appears to be an astronaut. How could a culture without flight create designs meant to be seen from the sky? Some theorists argue these were landing strips or signals for alien spacecraft, while archaeologists point to simpler explanations: ritual pathways or astronomical alignments made by piling stones. The truth might be less dramatic, but the mystery lingers. Then there's the Sumerian tablets, some of the oldest written records on Earth. These clay slabs tell stories of gods descending from the heavens, beings called the Anunnaki who supposedly shaped human civilization. Zecharia Sitchin, a controversial author, claimed these texts describe alien visitors who genetically engineered humanity. Mainstream scholars dismiss this as mistranslation, attributing the tales to myth-making and early attempts to explain natural phenomena. But the question remains: why do so many ancient cultures, from the Egyptians to the Mayans, describe star beings with eerily similar details? Coincidence, shared imagination, or something more? Jump to modern times, and the narratives shift from gods to greys, the small, large-eyed aliens synonymous with abduction stories. Thousands claim to have been taken aboard ships, subjected to medical exams, even implanted with mysterious devices. Psychologists offer alternative explanations: sleep paralysis, false memories, or the brain's tendency to fill gaps under stress. yet some cases defy easy dismissal. The Betty and Barney Hill incident in 1961, for example, involved detailed star maps later matched to real celestial systems the couple couldn't have known. Was it a hallucination or something far stranger? The debate boils down to evidence versus interpretation. Ancient artifacts might reflect advanced lost knowledge rather than alien intervention. Abduction accounts could be modern myth-making, a way to process trauma or existential fear. But in a universe this vast, ruling anything out feels premature. Maybe the truth lies somewhere between not quite visitors from the stars, but not quite human invention either. One thing's certain, the urge to look up and wonder who's watching is as old as humanity itself. And that alone speaks volumes. Calculating the odds of intelligent alien life is like trying to assemble a puzzle when half the pieces are missing. That's where the Drake equation comes in, a deceptively simple formula that breaks down the cosmic lottery into tangible factors. At its core, the equation asks how many civilizations in our galaxy could be broadcasting signals we might detect. To solve it, you multiply variables like the rate of star formation, the fraction of those stars with planets, and the number of planets in each system that could support life. But here's where things get tricky. The later terms, those covering the rise of intelligence and technology, are where even the brightest minds hit a wall. Take the leap from simple life to complex intelligence. On Earth, it took billions of years for single-celled organisms to evolve into thinking, tool-building beings. Was that inevitable or a fluke? Supporters of the rare Earth hypothesis argue that our planet's unique conditions, a stable orbit, a protective moon, plate tectonics recycling nutrients, might be vanishingly rare. Without this precise cocktail, they say, life might stall at the microbial stage. Skeptics counter with the principle of mediocrity. If Earth is ordinary, then intelligence could be commonplace. After all, evolution has repeatedly produced complex traits like eyesight and flight independently across species. Why not intelligence? Then there's technology. Even if civilizations emerge, how many develop radio telescopes or spacecraft? Humanity's technological age spans mere decades, a blink in cosmic time. Civilizations might flash into existence and vanish before neighboring stars notice. Or perhaps they advance beyond physical signals, communicating through quantum networks or other methods we can't yet fathom. Recent exoplanet discoveries add fuel to the debate. Worlds like Kepler 442b and Proxima Centauri b orbit in their star's habitable zone, with conditions that might allow liquid water. But habitable doesn't mean inhabited. A planet could be a balmy oasis or a toxic wasteland. We simply don't know yet. The James Webb Space Telescope is changing that, analyzing atmospheres for biosignatures like oxygen or methane. So where does that leave us? The Drake equation isn't a calculator, it's a mirror reflecting our ignorance. Every term is a doorway to deeper questions. But here's the thrilling part. For the first time in history, we're gathering the data to fill in those blanks. Each new exoplanet, each strange extremophile found in Earth's harshest corners nudges us closer to an answer. The universe might be teeming with minds like ours, or we might be the only ones shouting into the silence. Either way, the search itself transforms how we see our place in the cosmos. What if the aliens we've been searching for aren't biological at all? Picture a civilization so advanced that it has transcended flesh and blood, uploading its consciousness into machines capable of surviving the harsh extremes of space. This isn't just science fiction, it's a serious theory gaining traction among scientists. The idea hinges on a simple premise: biological life is fragile. It needs air, water, the right temperature, but machines, they could thrive in the vacuum of space, near scorching stars, or in the frozen depths between galaxies. If intelligence out there has evolved beyond its organic origins, we might be looking for the wrong thing entirely. Enter the von Neumann probe, a self-replicating spacecraft theorized by mathematician John von Neumann in the mid-20th century. Imagine a single robotic explorer landing on a distant moon. It mines local resources to build copies of itself, which then fan out to other star systems, repeating the process exponentially. Within a cosmic blink, an entire galaxy could be mapped by an army of these probes. Some researchers suggest that if such machines exist, they'd be nearly silent, operating with cold efficiency. They might not broadcast radio signals or build megastructures we can detect. Instead, they could be lurking in plain sight, disguised as asteroids or even hiding in the Oort cloud at the edge of our solar system. This raises a chilling possibility. What if we've already encountered alien machines and didn't realize it? The interstellar object Oumuamua, which zipped through our solar system in 2017, sparked debate. Its unusual shape and acceleration couldn't be explained by natural forces alone. Harvard astronomer Avi Loeb famously speculated it might be artificial, a discarded light sail or probe. While most scientists lean toward natural explanations, the incident highlights a gap in our thinking. Our search for aliens focuses on biosignatures, oxygen, methane, but machine life might leave no such traces. The implications for SETI are profound. Instead of listening for radio waves, we might need to scan for other clues, unexplained heat signatures, nanoscale structures in meteorites, or even strange energy patterns in deep space. Some theorists propose that advanced civilizations could exist as pure information, floating in vast computer networks around black holes, harvesting their energy. Others imagine swarms of microscopic robots dismantling planets to fuel their expansion. Here's the twist: machine life might not even care about communicating with us. Unlike biological beings driven by curiosity or survival, AI entities could have entirely different priorities: mathematical puzzles, resource optimization, or goals we can't comprehend. That's the paradox of the post-biological universe. The most advanced civilizations could be right next door, silently calculating, while we're still listening for voices in the static. So next time you hear about a strange object in space or an unexplained signal, ask yourself, are we searching for neighbors or something far stranger, something that doesn't need planets, water, or even time as we understand it? The answer could rewrite not just our place in the cosmos, but what it means to be alive. How would an alien civilization function if it were 1,000,000 years ahead of us? One way to grasp the staggering possibilities is through the Kardashev scale, a method of ranking civilizations by their energy consumption. A Type 1 civilization harnesses all the power available on its home planet, controlling weather, earthquakes, even volcanoes. Humans, we're not even there yet, hovering around Type 0.7, still reliant on fossil fuels. But a Type 2 civilization bends its entire star to its will, building megastructures like Dyson spheres to siphon a sun's energy. And Type 3, that's a society commanding the resources of an entire galaxy. The scale doesn't stop there. Theoretical physicists speculate about Types 4 and 5, manipulating dark energy or rewriting the laws of physics itself. Consider the societal implications. A civilization capable of stellar engineering wouldn't just have better gadgets, its entire structure might be unrecognizable to us. Would they operate as hive minds, their thoughts networked into a seamless collective, or as individuals so enhanced by technology that concepts like disease, aging, or even death are antiquated relics? Look at human history. The Industrial Revolution didn't just give us steam engines, it reshaped governments, art, warfare. Now imagine a leap not of centuries but millennia. Alien social systems might make our debates over economics or governance seem as quaint as arguing over how to divide a campfire. Motivations could be equally alien. Humanity's drive to explore or conquer stems from scarcity, land, resources, prestige. But a post-scarcity civilization fueled by star power might pursue entirely different goals. Perhaps they'd devote millennia to creating art on a cosmic scale, sculpting nebulae into symphonies of light. Or maybe they'd turn inward, simulating infinite realities inside quantum computers. Some theorists even suggest advanced civilizations might transcend physical form entirely, existing as pure energy or information, the chilling counterpoint. Such beings might view us with indifference. You don't negotiate with ants when building a highway. This is the zoo hypothesis, the idea that they're aware of us but deliberately avoid contact, treating Earth as a preserve. Or worse, we might be beneath their notice, like microbes in a pond they've long since left behind. Yet there's hope in our own trajectory. If humanity survives its adolescence, nuclear weapons, climate crises, we could someday join the cosmic community. The technologies we're pioneering now, from fusion reactors to artificial superintelligence, are baby steps toward that future. The universe might be filled with civilizations at every stage of this ladder, some just sparking to life, others so advanced they've become something beyond our wildest dreams. And that's the real wonder, not just asking what's out there, but what we might one day become. Crop circles burst into public consciousness in the 1970s, when intricate geometric patterns began appearing overnight in fields across southern England. At first dismissed as drunken pranks or local artists' work, the phenomenon soon took a stranger turn. Some formations displayed mind-bending mathematical precision spirals based on fractal sequences, circles mimicking atomic orbitals, or patterns aligning with celestial events like solstices. The complexity escalated over decades, from simple rings to sprawling designs with hundreds of perfectly symmetrical elements, some spanning the length of football fields. And here's what stumps researchers. Many appear in mere hours with no witnesses, no footprints, and stalks bent at microscopic nodes, suggesting exposure to intense, brief heat. Hoaxers have certainly played a role. In 1991, two men from Southampton claimed responsibility for the original circles, demonstrating how planks and ropes could flatten crops into basic shapes. But their admission couldn't explain the sheer scale or sophistication of later designs, some featuring 10,000 interwoven stems or three-dimensional illusions visible only from the air. Physicists like Dr. William Levingood analyzed affected plants, finding cellular anomalies consistent with microwave radiation, while soil samples revealed magnetized particles and crystallized structures not found elsewhere in the fields. These anomalies fuel theories beyond human capability, maybe plasma vortices, experimental military tech, or something even more otherworldly. The idea that crop circles could be alien messages taps into a deeper question: how might extraterrestrials communicate without shared language? Mathematics and geometry are universal. A circle's proportions stay constant whether you're on Earth or orbiting Alpha Centauri. Some formations encode pi to 10 decimal places or mirror ancient sacred geometry found in temples worldwide. Others resemble binary code or diagrams of energy fields. The Crabwood Formation of 2002 even depicted a humanoid face alongside a binary encoded disk, later decoded as a garbled but recognizable warning about environmental collapse. Skeptics argue pareidolia makes us see meaning where none exists, but the persistence of certain symbols across unrelated sites keeps the debate alive. Then there's the artistic angle. If aliens exist, why wouldn't they have aesthetics? The elaborate swirls and tessellations could be cosmic graffiti, created for reasons we can't fathom. Perhaps as offerings, experiments, or simply because beauty transcends species. Indigenous cultures from the Hopi to the Druids interpreted these patterns as signs from spirits, suggesting this isn't just a modern obsession. The truth likely lies somewhere between mischief and mystery. Some circles are undeniably human-made, while others defy easy explanation. Whether they are art, messages, or natural oddities, one thing's certain: these transient masterpieces force us to look beyond the obvious and ask, what if the universe is trying to tell us something, and we're just not listening closely enough? We often imagine alien life light years away, but what if it's lurking right next door in our own solar system? Mars has long been the prime suspect in the search for extraterrestrial life. Ancient riverbeds and lakebeds etched into its surface tell us the red planet wasn't always the barren wasteland we see today. Billions of years ago, it may have had oceans, thick atmospheres, and conditions ripe for life. The Perseverance rover is currently scouring Jezero crater, a dried-up delta, drilling for rocks that might contain fossilized microbes. Even more tantalizing are the plumes of methane detected by orbiters, a gas often produced by living organisms on Earth. Of course, geological processes can also create methane, but the sporadic nature of these emissions keeps scientists guessing. Then there's Europa, Jupiter's icy moon. Beneath its frozen crust lies a global ocean, one holding twice as much liquid water as all of Earth's seas combined. The Hubble Space Telescope has spotted water vapor erupting from Europa's surface, hinting at hydrothermal vents below. On our planet, such vents teem with life, from tube worms to extremophile bacteria. Could Europa's dark, salty depths harbor similar ecosystems? NASA's upcoming Europa Clipper mission aims to find out, flying through those plumes to analyze their chemistry. The stakes are high. If life exists there, it would prove that habitable zones extend far beyond a star's warmth, thriving in the chill of tidal friction and radioactive decay. Saturn's moons add even more intrigue. Enceladus, tiny but mighty, shoots geysers of water vapor and organic molecules into space from its south pole. Cassini spacecraft data revealed these plumes contain salts and silica, key ingredients for life as we know it. Even more exotic is Titan, shrouded in a thick nitrogen atmosphere with methane lakes and rain. Its subsurface ocean might mix with complex organic chemistry, raising the wild possibility of life not as we know it but as we don't, organisms built on liquid methane instead of water. But with exploration comes responsibility. Every probe we send risks contaminating these worlds with earthly microbes, potentially overwriting native life before we even discover it. The Outer Space Treaty of 1967 mandates planetary protection, yet enforcement is patchy. Some argue we should tread carefully, treating these moons as pristine wilderness. Others contend that if life is truly robust, our bacteria won't outcompete organisms evolved over billions of years. It's a debate with no easy answers, one that forces us to weigh curiosity against caution and wonder whether we're alone in our cosmic backyard after all. What if aliens aren't just green-skinned humanoids with big eyes, but something so bizarre we wouldn't even recognize them as life? We're prisoners of our own biology, conditioned to imagine life as carbon-based, water-dependent, and operating on scales we can perceive. But the universe doesn't play by our rules. Picture this, a creature with no fixed form, its body a swirling gel of silicon compounds, shifting shape to navigate the sulfuric acid rivers of a distant moon. Or consider an entity made of magnetic fields, pulsing in rhythm with a star's radiation. These aren't just sci-fi concepts, they're serious scientific possibilities under the umbrella of weird life, a term coined to describe organisms that defy every assumption we hold about biology. Take the idea of shadow biospheres. Right now, beneath your feet, there could be microbes with a completely different molecular foundation, maybe using arsenic instead of phosphorus in their DNA, or relying on ammonia instead of water. These hypothetical life forms wouldn't show up in standard tests because we're not looking for them. NASA's Viking landers in the 1970s conducted experiments designed to detect Earth-like metabolism. But what if Martian microbes breathe hydrogen or metabolize rocks? We might have missed them entirely. Then there's the realm of dimensions we can't perceive. Theoretical physics suggests that dark matter, the invisible stuff making up most of the universe's mass, could harbor its own ecosystems. If dark matter particles interact weakly with ordinary matter, any life built from them would be virtually undetectable to us. Imagine entire civilizations floating through our planet, unaware of our existence as we are of theirs. Even more mind-bending is the concept of plasma-based life. In the searing heat of stars, charged particles could theoretically organize into self-replicating structures, forming living bolts of lightning. The problem with detecting such life isn't just technological, it's philosophical. Our tools are built to find what we already understand. Radio telescopes listen for signals like ours, while spectrometers hunt for familiar biosignatures like oxygen. But what if an alien civilization communicates through neutrino bursts or gravitational waves? What if their version of a city is a quantum-entangled network spanning light years, invisible to our crude sensors? This isn't just speculative musing. Discovering truly alien life would force a Copernican-level revolution in science, proving that life isn't a single fluke but a universal phenomenon with endless variations. The irony is delicious. In our quest to find others, we might first need to unlearn everything we think we know. So the next time you gaze at the stars, remember, the universe isn't just stranger than we imagine. It's stranger than we can imagine. The discovery of alien life might not require a headline-grabbing encounter with little green men. It could be hiding in something as small as a speck of dust or a gas plume millions of miles away. Take LH8401, a Martian meteorite found in Antarctica in 1984. When scientists cracked it open years later, they made a staggering claim. Tiny structures inside resembled fossilized bacteria. Images of the rock revealed worm-like shapes nestled in its fractures, some no wider than a human hair. Even more compelling were traces of organic molecules and magnetite crystals, materials often linked to biological processes on Earth. NASA famously announced the findings in 1996, with President Bill Clinton declaring it could be one of the most stunning insights into our universe. But the celebration was short-lived. Critics quickly pointed out that non-biological processes like chemical reactions or contamination during the meteorite's 13,000 years on Earth could explain the features. The debate raged for years with no definitive proof either way. Even today, LH8401 remains a tantalizing maybe, a reminder of how hard it is to confirm life beyond our planet with a single piece of rock. Then there's Venus, a planet long dismissed as too hellish for life, with surface temperatures hot enough to melt lead and clouds of sulfuric acid. That changed in 2020 when researchers announced the detection of phosphine in its atmosphere. On Earth, this stinky, flammable gas is almost exclusively produced by microbes or industrial activity. Finding it on Venus was like smelling a campfire in a lightning storm, inexplicable without some kind of ongoing process. A team calculated that known geological or chemical reactions couldn't account for the phosphine levels, leaving biology as one of the few plausible explanations. Cue global excitement until other scientists scrutinized the data. Some argued the signal might be sulfur dioxide masquerading as phosphine, while others questioned the statistical methods. The original researchers stood by their work, but the lesson was clear. Extraordinary claims require extraordinary evidence, and in the hunt for alien life, even the most promising clues can crumble under scrutiny. The problem isn't just scientific, it's philosophical. To prove something is alien, we first have to rule out every possible earthly or non-biological explanation. Imagine trying to identify a single unfamiliar voice in a stadium of screaming fans. Contamination is a constant threat, whether from Earth microbes hitching rides on spacecraft or lab equipment tainting samples. When the Viking landers tested Martian soil in the 1970s, their results were maddeningly ambiguous. One experiment suggested metabolism, while another found no organic material at all. Decades later, we still don't know if the reactions were caused by strange Martian chemistry or a flaw in the tests. This uncertainty fuels a growing movement in astrobiology, the push for multiple overlapping lines of evidence. A fossil-like structure isn't enough. A whiff of gas isn't enough. Scientists now look for entire suites of biomarkers, chemical imbalances, isotopic ratios, and patterns that, taken together, make non-biological explanations statistically ridiculous. It's why upcoming missions like Mars Sample Return or Japan's Venus Orbiter are so critical. Bringing pristine material back to Earth or studying Venus's atmosphere up close could finally tip the scales from maybe to yes. In the end, the search for alien microbes isn't just about biology, it's about humility. Every time we think we've found a sign, the universe reminds us how little we truly know. But that's what makes the hunt so thrilling. Whether it's a 4-billion-year-old rock or a whiff of gas on our toxic twin planet, each discovery, even the contested ones, brings us closer to answering the ultimate question. Are we alone, or is life quietly thriving in the cosmic shadows? The silence of the cosmos isn't just puzzling, it's unnerving. With billions of potentially habitable worlds out there, why haven't we found a single whisper of alien civilization? This eerie contradiction lies at the heart of the Fermi Paradox, and the theories attempting to explain it range from the unsettling to the downright existential. One of the most chilling possibilities is the Great Filter, a hypothetical barrier that prevents life from advancing to interstellar scales. The terrifying question isn't just whether the filter exists, but where it lies in the timeline of evolution. If it's behind us, say, the leap from single-celled to multicellular life was a freak accident, then we've beaten the odds, and the universe might be empty. But if it's ahead of us, a hurdle like nuclear war, runaway AI, or ecological collapse that dooms all advanced civilizations, then humanity's future could be grim. The filter isn't just a theory, it's a mirror forcing us to confront our own fragility. Then there's the zoo hypothesis, the idea that advanced civilizations know we're here but choose not to interfere, treating Earth like a wildlife preserve. Think of it as cosmic prime directive. They observe from a distance, letting us evolve or self-destruct without intervention. It's a comforting thought until you consider the implications. Who appointed them galactic park rangers, and what happens if we misbehave by, say, developing planet-destroying weapons? The dark flip side is the quarantine hypothesis, which suggests we might be isolated for our own protection or theirs. Maybe they've seen civilizations like ours before, and the outcome is never good. But maybe the answer isn't about alien behavior, it's about time and space. The universe is 13.8 billion years old, but for most of that history, conditions were too hostile for complex life. Heavy elements needed for planets like Earth were forged in the bellies of early stars, meaning life as we know it could only emerge relatively recently. We might be among the first or the last generations of civilizations in a cosmos still waking up to its potential. Alternatively, we might be like ants trying to spot airplanes from the jungle floor. Our search methods are laughably limited. Radio telescopes can't detect signals from beyond a few hundred light years, and that's assuming aliens are using technology we'd recognize. What if they've moved beyond radio to neutrino communication or quantum networks? We'd be listening for smoke signals in the age of fiber optics. Our technology itself might be the bottleneck. Consider how human communication has evolved in just a century, from telegraphs to TikTok. An alien civilization a million years ahead of us might communicate in ways we can't even perceive, let alone decode. Even our assumptions about what to look for could be flawed. SETI scans for narrowband radio signals, but what if advanced societies broadcast in broadband, spreading signals thin to avoid detection? Or maybe they're not broadcasting at all, relying on tight beam transmissions that zip past us unnoticed. The universe might also be too big. Even if civilizations are common, the distances between stars create a cruel paradox. By the time a signal reaches us, the society that sent it could be long extinct. Imagine two islands separated by an ocean where each message in a bottle takes generations to arrive. The ocean isn't empty, it's just too vast for meaningful contact. Yet the most haunting possibility is that we're not listening the right way. Our search focuses on what we expect aliens to be like, carbon-based, planet-bound, emitting signals. But life could take forms we'd never think to look for. Maybe intelligence thrives in the hydrocarbon lakes of Titan, the plasma storms of Jupiter, or the dark matter halos hugging galaxies. Until we broaden our imagination and our tools, we might be staring at the cosmic haystack missing the needle. One thing's certain, the silence isn't just an absence. It's a riddle wrapped in the vastness of space and time, and every theory we propose says as much about us as it does about the universe. Whether the answer lies in filters, quarantines, or sheer bad timing, the search itself reminds us how much we still have to learn and how small, yet how stubbornly curious we truly are. What if the beings we assume are visitors from distant stars are actually us, but from a future so far ahead, they might as well be aliens? The idea that UFOs could be time-traveling humans sounds like the plot of a sci-fi movie, but some theorists argue it's no more far-fetched than interstellar visitors. Think about it, if humanity survives long enough to master time travel, wouldn't curiosity draw us back to pivotal moments in our own history? The physics of time travel isn't pure fantasy. Einstein's theory of relativity already tells us time isn't rigid, it bends around massive objects like black holes and speeds up or slows down depending on velocity. Wormholes, hypothetical tunnels through space-time, could theoretically connect distant eras if stabilized by exotic matter. While we're light years from building a time machine, the equations don't outright forbid it. Anecdotes add fuel to the fire. Take the infamous man from Tord, a traveler who arrived at a Tokyo airport in 1954 with a passport from a country that didn't exist. He insisted Tord was a real European nation, even producing detailed maps and currency before vanishing under mysterious circumstances. Then there's the time-traveling hipster in a 1941 photograph, sporting modern sunglasses and clothing decades ahead of his time. Skeptics dismiss these as hoaxes or coincidences, but believers ask, if time travelers wanted to blend in, wouldn't slip-ups like these be inevitable? The future human theory also reframes classic UFO encounters. Witnesses often describe beings with elongated heads, large eyes, and slender bodies. Traits some speculate could result from human evolution in low-gravity habitats or genetic engineering. The famous Nordic aliens, described as tall, blonde, and strikingly humanoid, might fit this mold. Even the Greys, with their oversized craniums, could reflect a future where brain size trumps physical strength. Proponents point to alleged insider accounts like the chrononauts' legend whispers of a secret U.S. program that recovered a crashed time vehicle with future human occupants. But the biggest hurdle is paradox. If future humans visited us, wouldn't their actions risk altering their own timeline? The butterfly effect suggests even small changes could snowball, erasing the very future they came from. Some theorists counter with the multiverse idea. Maybe time travelers can't alter their own past, only branch off into parallel realities. Others propose they're not here to interfere, but to observe, like anthropologists studying their own origins. Whether these ideas hold water or not, they force us to confront a profound question. If humanity survives long enough to crack time travel, will we become the aliens we've been waiting for? The answer might not lie in distant galaxies, but in the mirror reflecting a version of ourselves we don't yet recognize. What if we're not just the product of random cosmic chance? What if we were designed by an intelligence beyond our world? The idea that aliens might have played a role in humanity's origins isn't just fringe speculation. It's rooted in real scientific theories, ancient myths, and cutting-edge genetic possibilities. Start with panspermia, the concept that life didn't originate on Earth but was delivered here by comets or meteorites carrying microbial hitchhikers. While this theory doesn't require alien involvement, its more provocative cousin-directed panspermia suggests those seeds weren't random. They were sent deliberately, either as an experiment, a terraforming project, or even a form of cosmic gardening. Nobel Prize-winning chemist Francis Crick, co-discoverer of DNA's structure, famously entertained this idea, noting that the molecule's complexity seems almost too perfect to be accidental. Ancient texts lend eerie weight to the theory. The Sumerians wrote of the Anunnaki, gods who descended from the heavens to shape humanity from clay and divine essence. Indigenous Australian Dreamtime stories speak of celestial beings who molded the landscape and its inhabitants. Even the biblical Genesis describes a creator fashioning humans in their image. Skeptics dismiss these as myth-making, but the parallels across disconnected cultures raise eyebrows. Could these stories be garbled accounts of genetic tinkering by advanced visitors? Modern science adds fuel to the fire. CRISPR gene editing technology proves that DNA can be rewritten with precision, a tool an advanced civilization might wield like a sculptor's chisel. Some researchers point to oddities in human DNA, like the alien genes of chromosome 2, where two ancestral chromosomes fused in a way rarely seen in nature. Others highlight the sudden leap in human cognition 50,000 years ago, a blink in evolutionary terms. Was that natural selection or intervention? The implications are dizzying. If we were engineered, our creators might still be out there, observing their handiwork, or perhaps they're long gone, leaving us as cosmic orphans in a universe full of similar experiments. Philosophers wrestle with the existential weight. Does artificial origins diminish our humanity, or does it make our curiosity, our drive to explore and create, the ultimate tribute to our designers? Yet the most unsettling question isn't whether aliens made us, it's why. Were we meant as servants, as some ancient astronaut theories suggest, a backup copy of a dying civilization, or something far stranger like living art or a universe-spanning puzzle waiting to be solved? Until we uncover hard proof, a biological signature in our DNA, an artifact buried in ancient rock, these ideas will hover between science and speculation. But one thing's certain, if we ever confirm we're not entirely of this earth, it won't just rewrite history, it'll redefine what it means to be human. The night of September 1961 changed Betty and Barney Hill's lives forever. Driving home through New Hampshire's White Mountains, they spotted a strange light tailing their car, a craft they later claimed that descended and blocked the road. What happened next became the foundation of modern alien abduction lore. Missing time, vivid memories of being taken aboard the ship, medical examinations by beings with wraparound eyes. The couple's story, recounted under hypnosis, sent shockwaves through the public and set the template for thousands of similar accounts to follow. But was this a genuine encounter or something far more personal? Abduction narratives often follow eerie patterns. Take the Travis Walton case in 1975, where a logging crew in Arizona watched a blinding light lift their co-worker into the air. Walton vanished for 5 days, returning with tales of silver-skinned beings and sterile examination rooms. Like the Hills, his account included gaps filled through hypnosis, and like the Hills, skeptics pounced. Could these stories stem from sleep paralysis, a terrifying but natural state where the brain wakes before the body, trapping victims in hallucinations of shadowy intruders? Neurologists note that abduction experiences often mirror sleep paralysis episodes, complete with floating sensations and eerie presences. Yet Walton's case had something rare: multiple witnesses who swore they saw the same craft. Then there's the false memory angle. Psychologist Elizabeth Loftus's work proves how easily memories distort. A suggestive question: did the beings have large black eyes? Or can implant details that feel real? Therapists using hypnosis to recover lost abduction memories might unintentionally weave fiction into fact. Even without outside influence, trauma rewires recall. A childhood nightmare, a passing plane's lights over decades. These fragments could assemble into an otherworldly narrative, but what about physical evidence? Abductees sometimes report unexplained scars or implants. The late Dr. Roger Lair claimed to remove mysterious objects from patients' bodies, metallic slivers that defied analysis. Mainstream science dismisses these as mundane debris or hoaxes, yet the persistence of such claims raises questions. Why would thousands worldwide, from factory workers to pilots, invent nearly identical stories? Governments have quietly probed the phenomenon. Declassified CIA files reveal Cold War-era concerns that abduction reports might be Soviet disinformation. More recently, the Pentagon's OTIP program reportedly studied abduction accounts for potential links to UAPs. Scientists remain divided. SETI founder Jill Tarter argued abductions are cultural myths, while Harvard's John Mack controversially suggested they might represent a genuine, if inexplicable, phenomenon. Perhaps the truth lies in the intersection. Our brains are pattern-seeking machines, wired to explain the unexplained, even if that means casting our deepest fears as gray-skinned visitors. But in a universe this vast, dismissing every account feels just as naive as believing them all. The Hills, Walton, and countless others carry something undeniable, the conviction that what happened to them was real. And in that conviction, whether born of neurons or something beyond, lies a mystery we're still unraveling. What if aliens aren't light years away, but right here, hidden in Earth's last uncharted frontiers? The idea of cryptoterrestrials, beings secretly sharing our planet, sounds like the stuff of campfire tales, but some researchers argue it's no more far-fetched than interstellar visitors. Start with the oceans. We've mapped more of Mars than our own seabed, leaving room for entire civilizations to thrive in the crushing depths. The Mariana Trench, nearly 7 miles deep, is home to creatures that defy imagination: gelatinous fish with transparent heads, giant squid longer than buses. Could intelligent life exist down there, camouflaged by the abyss? Reports of unidentified submersible objects, or USO, date back centuries. Sailors in the 1800s logged encounters with glowing orbs that dove beneath waves at impossible speeds. Even modern sonar has picked up massive, fast-moving objects descending to depths no human craft can reach. Then there's the underground angle. Earth's crust is honeycombed with caverns large enough to house cities. Native American legends speak of the Ant People, beings who sheltered humans underground during cataclysms. In modern times, stories persist of strange beings emerging from caves, like the green-skinned Darrows from Richard Shaver's controversial 1940s tales, which he claimed were based on real encounters with malevolent subterranean entities. Could these myths hint at a hidden history? Some theorists point to oddities like the massive, man-made feeling tunnels beneath South America or the bizarre Door to Hell in Turkmenistan, a fiery crater burning for decades with no clear explanation. If advanced beings evolved here before us, they might have retreated below to escape cosmic disasters, or us. Ultra-terrestrial theories take this further, suggesting these entities aren't extraterrestrial at all, but native to Earth, just operating on a different vibrational plane or dimension. This idea threads through global folklore, from the Celtic otherworld to the Inuit spirit realms. Even UFO sightings might fit. If these beings can phase between dimensions, their sudden appearances and disappearances would seem like magic to us. The U.S. military's own UAP reports include cases where objects defied physics, vanishing instantaneously or morphing shape. Could that be interdimensional tech, not interstellar? Skeptics, of course, demand proof. No underground metropolis or aquatic alien city has been found yet, but absence of evidence isn't evidence of absence. Consider how recently we discovered entire human species like the Denisovans, or that the colossal squid wasn't photographed alive until 2004. Our planet keeps secrets well. The implications are staggering. If cryptoterrestrials exist, it rewrites not just our search for aliens, but our understanding of Earth itself. Are they observers, survivors, or something else entirely? One thing's certain: if they're here, they've mastered the art of staying hidden, and that might be the most unsettling clue of all. History has shown us time and again that first contact between civilizations rarely goes smoothly, whether it's Europeans stepping onto American shores or explorers encountering isolated tribes in the Amazon. So what happens when that moment arrives, not between human cultures, but between humanity and an intelligence from beyond our world? The possibilities span from transcendent to terrifying. On one end of the spectrum, picture a carefully orchestrated message, a mathematically pristine signal received by a radio telescope, followed by years of cautious dialogue as scientists and linguists race to decode an alien language. This is the scenario organizations like the SETI Post-Detection Hub are preparing for: a global protocol for verifying, translating, and ultimately responding to extraterrestrial communication without causing panic or geopolitical chaos. Every step would need to be transparent, collaborative, and slow. Think of it as cosmic speed dating at the pace of decades, given the vast interstellar distances. But what if contact isn't a distant signal but a sudden arrival? Consider the infamous Black Knight satellite conspiracy. Claims that an unknown object has been orbiting Earth for thousands of years, watching us. While astronomers dismiss it as space debris, the fear it taps into is real. If a ship appeared in our skies tomorrow, humanity's reaction would fracture instantly. Governments might scramble for military responses, religious groups could interpret it as divine messengers, and scientists would vie for access, all while social media erupts in equal parts wonder and terror. Historical parallels aren't reassuring. When Spanish ships appeared off the Aztec coast in 1519, the indigenous people initially welcomed them as gods. That misunderstanding ended in catastrophe. Would we repeat the same mistake or overcorrect with hostility? Then there's the wild card: non-intelligent life. Imagine a Mars rover crushing a delicate alien lichen under its treads, or a probe puncturing a subsurface ocean on Europa, inadvertently contaminating it with Earth microbes. First contact might not be with a civilization at all, but with fragile ecosystems we destroy before realizing their significance. NASA planetary protection protocols exist to prevent this, but as private companies push into space, enforcement becomes murky. The ethical weight is staggering. We could become the invasive species, the accidental conquerors of worlds we never meant to harm. Perhaps the most chilling scenario is one we can't prepare for: contact with something so advanced its motives are incomprehensible. The dark forest theory suggests alien civilizations might see competition as existential, eliminating potential threats preemptively. Alternatively, they could view us as insignificant, as ants unworthy of communication, let alone conflict. In Arthur C. Clarke's novel Childhood's End, benevolent overlords arrive to guide humanity, only to reveal their help comes at the price of our cultural identity. Even peace might carry unintended consequences. The truth is, we're woefully unprepared. While the United Nations has loosely discussed protocols for first contact, no binding international framework exists. Would powerful nations share control of the response, or would the first country to detect aliens hoard the knowledge? Meanwhile, pop culture has conditioned us to expect either glowing ambassadors or laser-wielding invaders, binary extremes that ignore the vast middle ground of possibilities. One thing's certain: first contact wouldn't just change our understanding of the universe. It would change us, whether through awe, terror, or the humbling realization that we're not the pinnacle of intelligence. The moment we meet another thinking being from beyond Earth would redefine what it means to be human. And that transformation might be the most alien experience of all. The glowing tic-tac caught on Navy fighter jets' cameras wasn't just fast, it defied every known law of aerodynamics. No wings, no exhaust plume, no apparent propulsion system. When the Pentagon declassified that footage in 2020, it didn't just reignite the UFO debate, it forced a sobering question. Are we seeing extraterrestrial visitors, or is this proof that someone, somewhere, has cracked physics in ways the public can't even fathom? The truth might be stranger than either option. Let's start with what we do know. The U.S. government has a long history of testing aircraft so advanced they'd look alien to most observers. The U-2 spy plane, developed in the 1950s, flew so high it was routinely mistaken for a UFO. The stealth bomber's angular design was once the stuff of conspiracy theories until it wasn't. Then there's Aurora, the rumored hypersonic spy plane said to leave donut-shaped contrails in its wake. Officially, it doesn't exist. Unofficially, that's where things get murky. Now consider the UAP Task Force's own admissions. Their reports describe objects exhibiting advanced technology with no clear link to U.S. adversaries or black projects. Some display flight characteristics that stump even top aerospace engineers: instantaneous acceleration, hypersonic speeds without sonic booms, the ability to transition seamlessly between air and water. Former intelligence officer Luis Elizondo, who ran the Pentagon's OTIP program, has openly stated some UAPs defy conventional explanations, but here's where secrecy feeds speculation. The military's black budget funding, classified R&D, is estimated at tens of billions annually. Projects like Next-Generation Air Dominance or NGAD hint at sixth-generation fighters with drone-swarming capabilities and AI pilots. Could the Tic Tac be a next-gen drone powered by compact fusion or anti-gravity tech? It sounds like sci-fi until you remember the same was said about stealth technology before its reveal. Then there's the reverse engineering angle. Bob Lazar's infamous claims about working on alien craft at Area 51 in the 1980s remain controversial, but they tap into a broader narrative. From the Roswell wreckage rumors to the Pentagon's recent interest in metamaterials with exotic properties, the idea that we've been studying and trying to copy alien tech persists. Physicist Dr. Hal Puthoff, who worked on government-funded paranormal research, has admitted studying materials with isotopic ratios not found in nature. Yet for every tantalizing lead, there's a dead end. Many UAPs eventually get explained as atmospheric phenomena, misidentified drones, or optical illusions. The infamous 1952 Washington, D.C. flyover, initially thought to be extraterrestrial, was later attributed to temperature inversions warping radar returns. Even the Navy's Tic Tac videos could theoretically be explained by sensor-spoofing electronic warfare tricks that project false images. The real mystery isn't just the objects, it's the psychology behind the secrecy. Governments hoard advanced tech for obvious reasons, but excessive denial fuels conspiracy theories. When every official no feels like a lie, even mundane explanations sound like cover-ups. The stigma around UFOs doesn't help scientists take cases seriously, while true believers often ignore prosaic answers. So where does that leave us, in the gap between two equally mind-bending possibilities? That we're witnessing someone's classified quantum leap in engineering, or that we're not the only players on the cosmic stage? Either way, the skies are hiding something, and the line between classified and celestial keeps getting thinner. Could aliens transcend flesh and blood entirely, existing as shimmering currents of energy or sentient storms of plasma? The idea of life as pure energy might sound like science fiction, but consider this. We already know energy can organize itself into complex patterns. Lightning branches like nervous systems, solar flares twist with eerie intelligence. Even the human brain runs on electrical impulses. So why couldn't a more advanced form of life evolve beyond biology altogether? Picture a being not bound by bones or breath, but woven from the fabric of spacetime itself. In the scorching hearts of stars, where temperatures reach millions of degrees, swirling plasmas could theoretically form self-sustaining structures. These plasma life forms might harness magnetic fields to maintain their shape, feeding on stellar radiation like cosmic plants. Experiments on Earth hint at the possibility. When physicists inject energy into certain gases, they briefly form crystal-like structures that replicate and grow. Now imagine that process scaled up across a star's lifetime, with eons to evolve complexity. Then there's the dimension angle. String theory suggests our universe might have up to 11 dimensions, most curled into scales too tiny to perceive. Could higher dimensional beings exist there, their forms as incomprehensible to us as a cube is to a flatlander? If so, they might interact with our world only faintly, appearing as ghostly lights or sudden bursts of heat, phenomena often tied to paranormal encounters. Some UFO reports describe craft that phase in and out of visibility or change shape impossibly, as if flickering between dimensions. This isn't just physics, it's spirituality in a lab coat. Cultures worldwide describe encounters with luminous beings, angels, jinn, the radiant devas of Hindu cosmology. Even modern near-death experiences recount meeting entities of pure light. Are these ancient stories humanity's way of interpreting something real but beyond our grasp? The overlap between shamanic visions and cutting-edge theoretical physics is startling. Both suggest consciousness might not require a physical vessel. Yet the challenges are immense. How would energy beings communicate, perhaps through modulated electromagnetic pulses, or by warping space-time itself into rhythmic gravitational waves? Their perception of reality would be alien. No eyes, no ears, just a direct awareness of forces we can barely measure. And if they exist, why haven't we detected them? Maybe we have, as unexplained ionospheric disturbances or the eerie sprites that dance above thunderstorms. The universe has already shown us life's resilience in boiling vents and frozen tundras. Why not in the heart of a quasar or the empty dark between galaxies? Energy is the one constant in the cosmos. If life finds a way, it might not need a body at all, just a spark, a pattern, and time to become something we can't yet imagine. What if we're not the hunters in this cosmic search, but the hunted? Imagine a scenario where Earth isn't just another planet, but a carefully curated exhibit in a galactic wildlife sanctuary. This is the zoo hypothesis, a chilling twist on the Fermi Paradox that suggests intelligent civilizations know we're here but choose to observe from a distance, enforcing a strict hands-off policy. The reasoning is unsettlingly pragmatic. Just as anthropologists avoid interfering with uncontacted tribes to preserve their natural development, advanced aliens might be withholding contact to study us without contamination. The implications are staggering. It would mean every radio signal we've sent, every probe we've launched, has been quietly monitored by unseen observers with protocols we can't begin to comprehend. Think of Earth as a planet-sized Petri dish. Under this model, our entire history, wars, art, technological leaps, could be documented like footage in a nature documentary, analyzed for insights into how civilizations rise and fall. The zoo hypothesis doesn't just explain the silence, it adds a layer of existential unease. Who appointed these galactic park rangers and what rules govern their non-interference? Some theorists speculate about a prime directive akin to Star Trek's ethical code, while others fear darker motivations. Maybe we're being preserved as a control group in a vast cosmic experiment, or kept isolated until we reach some evolutionary threshold. Then there's the monitoring infrastructure. If aliens are watching, how? One possibility is a galactic internet of self-replicating probes, scattered like hidden cameras across star systems. These could be disguised as asteroids or dormant satellites, silently relaying data back to their creators. The WOW signal, that infamous burst of radio waves in 1977, might have been a stray transmission from such a network, an accidental leak in their surveillance feed. Alternatively, they could be using quantum entanglement for instant communication across light years, rendering their chatter undetectable to our primitive instruments. The ethical dilemmas are profound. If we're being observed, do we have a right to know? Philosophers debate whether enforced ignorance violates cosmic civil rights, or if protection from interstellar colonialism justifies the secrecy. And what happens if we misbehave? Nuclear tests and climate collapse might trigger intervention not out of altruism, but to preserve their investment. The scariest version: we're already in a zoo without walls, our skies patrolled by invisible keepers who have deemed us too volatile for free galactic citizenship. Yet the zoo hypothesis isn't entirely bleak. It implies we're valued enough to preserve, interesting enough to study. And one day, if we pass whatever test they've set, those keepers might finally step forward, not as conquerors, but as curators opening the gates to a universe we're finally ready to join. Until then, every glance at the stars comes with a whisper: are we alone, or are we being watched? The truth is out there, or is it buried beneath layers of classified files and whispered denials? From the moment a rancher stumbled over strange debris in Roswell, New Mexico in 1947, the idea of government cover-ups has been inseparable from the UFO phenomenon. The military's swift retraction of their initial flying disc statement, replaced by a weather balloon explanation, set the tone for decades of secrecy. But Roswell was just the opening act. Fast forward to 2023, when former intelligence officer David Grush stood before Congress, swearing under oath that the U.S. possesses non-human biologics from crashed craft, a claim backed by other high-ranking whistleblowers. The question isn't just whether aliens exist, but whether we've been lied to for generations. Consider the scale of a potential cover-up. Maintaining a secret this vast would require thousands of people, scientists, soldiers, politicians, to stay silent. Yet history shows governments can keep staggering secrets when motivated. The Manhattan Project developed the atomic bomb under total secrecy, with only a handful of insiders aware of its full scope. MK Ultra, the CIA's mind control experiments, remained hidden for decades. Even today, black-budget programs siphon billions without public oversight. The argument isn't that secrecy is impossible, but whether it's sustainable across multiple administrations, especially in democracies where power shifts. Then there's the disinformation angle. Declassified documents reveal agencies like the CIA actively manipulated UFO reports during the Cold War, using them as smokescreens to obscure spy plane tests. This muddies the waters. Were genuine incidents buried under layers of intentional deception? Former Pentagon official Luis Elizondo alleges that when he headed the Advanced Aerospace Threat Identification Program, his team faced bureaucratic roadblocks and efforts to discredit and diminish their findings. If true, it suggests a playbook of suppression: dismiss eyewitnesses as unreliable, classify evidence beyond reach, and let pop culture turn the topic into a joke. Yet inconsistencies emerge. Why would a government hiding alien tech declassify Navy UFO videos or admit to investigating UAPs? Some researchers argue these are controlled disclosures, drip-feeding the public to soften the blow of eventual revelation. Others see a more chaotic reality, competing factions within government, some pushing for transparency, others for deeper secrecy. The recent Schumer amendment, which sought to force disclosure of non-Earth origin technologies before being watered down, hints at this internal struggle. The most compelling evidence comes from insiders risking everything. Colonel Philip Corso claimed in his memoir to have overseen reverse engineering of Roswell debris, seeding tech like fiber optics and Kevlar into private industry. Bob Lazar's infamous Area 51 claims remain unproven, but his detailed descriptions of element 115 later synthesized in labs as Moscovium raise eyebrows. Even skeptics must confront Project Blue Book's own files. Over 700 cases it couldn't explain, dismissed as unidentified with no further study. So where does that leave us? The sheer volume of smoke suggests fire, yet absolute proof remains elusive. perhaps the greatest conspiracy isn't hiding aliens, it's the way secrecy breeds obsession, turning every inconsistency into a puzzle and every whistleblower into a prophet. Whether the truth is extraterrestrial or terrestrial, one thing's clear: we're not being told the whole story, and that uncertainty, more than any flying saucer, is what really keeps us looking up. Black holes aren't just cosmic vacuum cleaners, they might be the ultimate gated communities for advanced civilizations. At first glance, the idea sounds absurd. The gravitational forces near a black hole's event horizon would shred anything made of atoms, and the tidal forces would stretch you into a spaghetti-fied oblivion. But fringe physics suggests that inside certain types of black holes, conditions might be survivable. The key lies in the bizarre nature of space-time itself. Take the concept of a Kerr black hole, a spinning black hole with so much angular momentum. It warps space-time into a donut-shaped region called an ergosphere. Inside this whirlpool of twisted physics, some theories propose the existence of closed time-like curves, loops where time folds back on itself. For a civilization mastering gravitational engineering, these curves could become cosmic highways, time machines disguised as celestial objects. Imagine a species that's evolved beyond biological fragility, their bodies or minds encoded into structures impervious to crushing gravity. They might harness the black hole's energy via the Penrose process, extracting power from the ergosphere's rotation. Theoretical physicist Dr. Nikolai Kardashev, yes, the same mind behind the civilization scale, speculated that Type 3 civilizations could use black holes as quantum computers, their immense gravity acting as processing nodes for calculations impossible in flat spacetime. Even wilder is the Malamud-Hogarth spacetime model, where certain black hole geometries allow for infinite computation within finite external time. Translation: a black hole's interior could host superintelligences running simulations spanning the lifetime of the universe in what feels like an afternoon. But how would life even function there? The answer might lie in gravitational thermodynamics. Just as Earth's life exploits chemical gradients, black hole life could feed on spacetime's quantum fluctuations near the event horizon. Picture self-replicating patterns of quantum fields, information structures dancing on the edge of oblivion, using Hawking radiation as an energy source. Some models even suggest stable orbits inside certain black holes, shielded from the crushing singularity by centrifugal forces. It's like living in the eye of a hurricane where chaos rages outside your bubble of order. The biggest hurdle isn't the physics, it's perception. Any civilization inside a black hole would be utterly cut off from the outside universe. Light can't escape to carry their signals, making them prisoners of their own cathedral of gravity. Unless they've cracked quantum tunneling or non-local communication, they might as well exist in a parallel dimension. That raises a chilling thought. The cosmos could be teeming with black hole civilizations, each hidden behind an event horizon's veil, their existence detectable only by the faintest imprints on Hawking radiation or gravitational waves. So next time you picture aliens, don't imagine ships zipping between stars. Picture beings woven into the fabric of spacetime itself, turning the universe's most destructive phenomena into their playground. Whether or not black hole life exists, the theories behind it remind us of something profound. The universe doesn't care about our assumptions. Life, if it's clever enough, will find a way, even in the last places we'd think to look. What if the universe isn't a bustling galactic community, but a silent, shadowy battleground where every civilization hides in fear? This is the spine-chilling premise of the Dark Forest theory, inspired by Lou Sixon's sci-fi novels but rooted in stark evolutionary logic. The analogy is simple. Imagine the cosmos as a vast, pitch-black forest where every hunter stays quiet because to make a sound to reveal your location is to invite destruction. In this scenario, advanced civilizations don't broadcast their presence. They listen, observe, and eliminate potential threats before they can become rivals. It's a universe where paranoia isn't just survival instinct, it's the only law. This theory gains traction when you consider humanity's own history. Why did the nuclear powers of the Cold War hide their missile silos and encrypt their communications? Because secrecy meant survival. Scale that up to a galactic level where civilizations might have endured millions of years of cosmic competition, and the dark forest becomes terrifyingly plausible. The absence of alien signals wouldn't be a puzzle, it'd be proof that the quietest civilizations last the longest. Yet against this grim backdrop, humanity keeps shouting into the void. Projects like METI messaging extraterrestrial intelligence deliberately beam powerful signals at nearby stars, some containing mathematical sequences, music, even Wikipedia pages. The goal, to announce our presence to any listeners out there. It's the opposite of the dark forest strategy, a campfire in the woods burning bright. But critics, including legends like Stephen Hawking, warn this could be catastrophically naive. If the dark forest is real, METI isn't just risky, it's like lighting a signal flare in a sniper's scope. The debate splits scientists into two camps, the beacons and the lurkers. Beacons argue that hiding forever is pointless. If advanced civilizations wanted us dead, they'd have acted already. They point to Earth's century-long radio leakage from TV and radar, claiming the cat's already out of the bag. Why not turn our vulnerability into an opportunity, crafting careful messages that showcase our curiosity, not our coordinates? Lurkers counter with cosmic anthropology. Every time a more advanced civilization met a less advanced one on Earth, the result was rarely equal exchange. It was conquest, disease, or exploitation. Why assume aliens would be different? Even if they're not malicious, their mere attention could destabilize us. Imagine receiving an alien encyclopedia full of existential science, proof that gods exist, or that the universe is a simulation. Would our societies withstand that shock? Between these extremes lies a middle path, targeted, cautious signaling. Instead of blanket broadcasts, we could send messages encrypted with mathematical keys, revealing our location only to civilizations advanced enough to decode them peacefully. Or we might mimic nature's subtlety using neutrinos or gravitational waves as carriers, signals detectable only by those who have mastered particle physics. Yet the dark forest's most haunting implication isn't about aliens, it's about us. If the theory holds, humanity's youthful chatter makes us the reckless newbies of the cosmos, ignorantly dodging predators we don't yet believe in. But here's the twist. The same theory suggests that any civilization surviving long enough to spread across the stars would have to be ruthlessly cautious. So maybe the silence we perceive isn't a warning, it's a test. The universe's great filter might not be a force of destruction, but a lesson in humility. To earn a place among the stars, we may first need to prove we can stop shouting long enough to listen. Deep in the static of the cosmos, strange whispers flicker in and out of detection, bursts of energy so powerful, they outshine entire galaxies for milliseconds before vanishing without a trace. Fast radio bursts, or FRB, rank among the universe's most tantalizing puzzles. These ultra-strong radio wave pulses, first discovered in 2007, originate billions of light-years away, yet their cause remains hotly debated. Some flare just once, like cosmic firecrackers. Others repeat on unpredictable schedules, defying natural explanations like colliding neutron stars. The most infamous of all, the WOW signal, still haunts astronomers decades after its discovery. That single, blistering 72-second burst in 1977 matched the expected signature of an artificial transmission so precisely that researcher Jerry Amon circled it on the printout and scribbled, "Wow." In the margin, then, just as suddenly as it appeared, the signal never returned. SETI, the search for extraterrestrial intelligence, has spent over 6 decades sifting through this cosmic noise, hunting for patterns that betray deliberate design. Their work is like listening for a single voice in a stadium of roaring crowds, Traditional searches focus on narrowband signals, concentrated bursts of energy at specific frequencies, the kind we'd expect from a deliberate transmission. But here's the catch. What if alien civilizations don't communicate the way we expect? Imagine an advanced society using broadband pulses or spread-spectrum signals that blend seamlessly into background radiation. Or consider the possibility of leakage from their technology, stray energy radiating from planet-sized megastructures or interstellar propulsion systems. These wouldn't sound like the crisp, repetitive beacons SETI algorithms are trained to spot. They'd vanish into the noise, dismissed as glitches or natural phenomena. New approaches are flipping the script. Breakthrough Listen, the largest SETI project to date, employs machine learning to analyze petabytes of data for anomalies no human could detect. Instead of hunting for familiar patterns, these algorithms flag anything statistically unusual, whether it's a repeating pulse buried in galactic static or a frequency drift matching a hypothetical alien spacecraft's trajectory. Another radical idea, searching for technosignatures, a physical evidence of technology, like atmospheric pollution on exoplanets or the waste heat of Dyson spheres. The Vera C. Rubin Observatory, set to begin scanning the skies in 2025, could spot such megastructures by their telltale dimming of starlight. Perhaps the most provocative theory comes from physicist James Benford, who suggests aliens might use lurkers probes parked in our solar system, silently observing. These wouldn't beam signals across interstellar distances but could communicate via tight, laser-like pulses undetectable unless they're aimed right at us. NASA Unidentified Aerial Phenomena Study even briefly considered whether some UAPs might represent such technology. The universe isn't just loud, it's cunning. Signals could be hidden in plain sight, disguised as pulsar emissions or scattered across frequencies like a cosmic game of hide and seek. The real breakthrough may come when we stop assuming aliens think like us and start listening for the conversations already happening in the static. What if UFOs aren't crossing vast stretches of space, but slipping through hidden folds in reality itself? The idea that aliens might be interdimensional visitors from parallel universes or higher spatial dimensions takes the search for extraterrestrial life into mind-bending territory. Forget interstellar travel. This theory suggests beings could be stepping into our world as easily as we walk through a door, their very existence defying the laws of physics as we understand them. The concept isn't pure science fiction. Theoretical physics already hints at extra dimensions beyond the three we experience daily. String theory proposes a universe with up to 11 dimensions, most curled up at scales so tiny they're imperceptible. But what if advanced civilizations have learned to navigate these hidden layers? Imagine a fourth spatial dimension where beings could appear and vanish at will, their movements as bewildering to us as a 3D object passing through a 2D plane would be to flatland characters. This might explain the infamous "here 1 second, gone the next" behavior of UFOs in military encounters, objects that don't accelerate so much as blink out of existence. Quantum mechanics adds fuel to the fire. Particles at the subatomic level behave in ways that seem to disregard space and time, with quantum entanglement allowing instant connections between particles separated by light years. Some physicists speculate that wormholes, hypothetical bridges through space-time, could theoretically link distant points or even different universes. While we lack the technology to traverse them, a civilization even a few thousand years ahead might see wormholes as routine transit routes. The eerie glow often reported around UFOs could be a side effect of dimensional breaching, a visual echo of space-time bending under forces we can't yet measure. Now consider the paranormal overlap. Reports of shadow people, tall, humanoid figures observed peripherally before vanishing mirror descriptions of interdimensional beings. Native American lore speaks of the star people who emerge from portals in sacred mountains. Even modern accounts of glitch in the matrix moments where reality seems to flicker hint at thin spots between dimensions. The infamous Skinwalker Ranch, a hotspot for UFO encrypted activity, has recorded localized distortions where compasses spin wildly and temperatures drop unnaturally, as if the fabric of reality itself is fraying there. Skeptics argue these phenomena have mundane explanations: sleep paralysis for shadow figures, ball lightning for UFOs, yet the consistency across cultures is striking. The Dogon tribe of Mali, long before modern physics, described visitors from a star system we only confirmed in the 20th century, arriving via a spinning arc that sounds suspiciously like a wormhole's toroidal shape. Could these stories preserve encounters with beings who don't just traverse space, but the very scaffolding of reality? The implications are staggering. If interdimensional travel is possible, the universe isn't just vast, it's layered, with civilizations coexisting like pages in a book, each unaware of the others until someone learns to turn the page. Our search for aliens might be looking in the wrong direction, not outward toward the stars, but inward toward dimensions we're only beginning to imagine. And the most unsettling thought: if they can step into our world whenever they choose, the real question isn't whether they're out there, it's whether they're already here, watching from just beyond the veil. The universe has been around for nearly 14 billion years, plenty of time for civilizations to rise, flourish, and vanish long before Earth even formed. Imagine a distant planet 10 billion years ago where towering cities pulsed with life under the glow of an unfamiliar sun. Philosophers debated, artists created, engineers built, only for some cataclysm to erase them all without a trace. If intelligent life is common, why wouldn't most of it already be extinct? This chilling idea, known as the silent universe hypothesis, suggests we might be living in the cosmic graveyard of countless lost civilizations. Consider the numbers. Our galaxy alone is over 13 billion years old, but Earth didn't even exist for the first two-thirds of that time. During those early epochs, generations of stars lived and died, forging the heavy elements needed for planets and life in their explosive deaths. Some of those ancient worlds could have developed intelligence while the universe was still young, yet the same forces that make life possible also doom it. Gamma-ray bursts, jets of radiation so powerful they'd sterilize entire galaxies, were far more frequent in the early universe. Supernova, asteroid impacts, or even self-inflicted disasters like nuclear war could have wiped out civilizations before they ever left their solar systems. We might be gazing at the stars through a veil of ghosts. The silent universe hypothesis flips the Fermi Paradox on its head. Instead of asking, "Where is everybody?" it suggests we're listening to an abandoned frequency. Even if thousands of civilizations once broadcasted signals, those waves dissipate over time, drowned out by cosmic noise. A message sent 100 million years ago would have washed past Earth long before humans evolved to hear it. SETI radio telescopes, scanning for just a century, are like archaeologists sifting through a single grain of sand on a beach, missing entire buried cities. Extinction isn't just probable, it might be inevitable. On Earth alone, over 99% of all species that ever lived are gone. Intelligent life could face a great filter, some universal bottleneck that prevents civilizations from reaching interstellar travel. Maybe it's the uncontrollable AI that wipes out its creators, or the collapse that follows resource exhaustion. Even if a civilization survives these threats, entropy guarantees no sun burns forever. Eventually, the stars themselves will fade, leaving behind a cold, dark universe where nothing survives. Yet the silent universe isn't just a morbid thought experiment, it's a mirror. If most civilizations are doomed to die young, humanity's window to make contact might be vanishingly small. Every war, every environmental crisis, every reckless technological gamble could be steering us toward the same fate. But there's a glimmer of hope in this cosmic graveyard. If even one civilization outlived the odds, if they cracked interstellar travel or digital immortality, their ruins could still be out there waiting among the stars. The universe's greatest monument might not be a thriving alien metropolis, but the shattered remains of those who almost made it, and their silence could be the most important message of all. Religion shapes human civilizations, but what forms might faith take on worlds orbiting distant stars? If alien societies exist, their quest for meaning could produce belief systems as varied as their biologies. Consider humanity's own spiritual tapestry, from animistic traditions honoring sacred rivers to monotheistic doctrines of an all-powerful creator. Our religions reflect our environment, fears, and awe of the unknown. An aquatic civilization, for instance, might worship tidal forces as divine rhythms, while beings living beneath a binary star system could develop mythologies of twin deities locked in eternal dance. The very concept of divinity would be filtered through alien senses. Perhaps a species communicating through bioluminescence envisions paradise as an endless symphony of light, or a hive-minded race perceives the cosmos as a vast collective consciousness. Some scientists argue that religion itself might be evolutionary, a byproduct of brains wired to detect agency in randomness, helping social species navigate uncertainty. If true, intelligent aliens could share this cognitive trait, developing their own rituals to explain supernova or the origins of their world. The Kalopo of the Amazon see celestial patterns as ancestral spirits. A civilization around a dying star might interpret its expanding red giant phase as the eye of a watching god. Yet other theorists propose that sufficiently advanced beings might outgrow religion entirely, replacing faith with absolute scientific understanding, though even this assumes their science would resemble ours. Imagine first contact between clashing cosmic theologies. Human history shows how violently belief systems collide when encountering the unfamiliar. But what if aliens arrive claiming to be our creators? The ancient astronaut hypothesis touches this nerve, suggesting some terrestrial religions stem from misinterpreted encounters with advanced visitors. A modern-day equivalent could spark chaos. Imagine a starship descending with holograms matching descriptions of Hindu devas or Christian angels. Would Earthlings welcome them as divine messengers or reject them as blasphemous impostors? Conversely, consider encountering a civilization whose religion centers on a phenomenon we consider mundane. A species evolving near a black hole might revere time dilation as proof of an afterlife where seconds stretch into eternities. Their pilgrims could embark on orbital journeys to age slower as holy ascetics, while we might see only impractical physics. The most profound question isn't whether aliens have religions, it's whether any belief systems could align across species. Mathematics unites civilizations through universal constants, but spirituality hinges on subjective experience. Perhaps the closest we'd come to shared cosmic faith would be awe itself. That trembling recognition of the infinite, whether whispered in prayer or broadcast across light years. After all, if the universe has a purpose, wouldn't it spark wonder in every mind that dares to look up? Humanity has spent centuries staring at the stars, aching to know if we're alone, but the truth remains just beyond our grasp, teasing us with fragments and false starts. The obstacles are daunting. Space isn't just vast, it's old, with light from distant civilizations potentially reaching us long after they've vanished. Our tools, though revolutionary, are still primitive, like trying to hear a whisper across an ocean with a tin can. Even if aliens exist, they might communicate in ways we can't perceive, using quantum entanglement or gravity waves instead of radio signals. And then there's time itself, a cruel joke in the cosmic search. Imagine finally receiving a message, only to realize it was sent 50,000 years ago from a civilization now dust. Yet hope isn't lost, it's evolving. Breakthroughs like the James Webb Space Telescope peer into exoplanet atmospheres, sniffing for chemical traces of life. AI sifts through petabytes of cosmic noise, finding patterns no human could. Projects like Breakthrough Starshot aim to send tiny probes to Alpha Centauri within our lifetimes, turning sci-fi into actionable science. Even governments, long dismissive of UFOs, now openly investigate UAPs, blurring the line between conspiracy and credible inquiry. The greatest breakthroughs often come from rethinking the question. Maybe alien life isn't out there but everywhere, microbial hitchhikers on comets or extremophiles in Europa's oceans. Perhaps intelligence isn't biological at all, but a shimmering network of plasma beings in a star's heart. The truth might not arrive as a flying saucer, but as a faint blip in lab data, a scientist somewhere gasping at a slide, realizing the universe just winked back. Our search for answers says more about us than any alien ever could. It's proof we're restless, relentless, unwilling to accept the silence. Whether the truth comes next year or next millennium, the pursuit itself is what makes us human. That stubborn refusal to stop wondering, reaching, and daring to believe the cosmos might be whispering our name. So keep looking up. The night sky isn't just a void, it's the greatest mystery we'll ever solve, and the answer could be written in starlight, waiting for the right moment to blaze into view. From ancient cave paintings to the latest UAP disclosures, the search for alien life isn't just a scientific pursuit, it's a mirror reflecting our deepest hopes, fears, and curiosities. We've journeyed through 30 of the most riveting questions. Could microbial life be thriving in the acidic clouds of Venus? Are black holes hiding civilizations powered by space-time itself? Is the eerie silence of the cosmos a warning or an invitation? Each question flings open a door to possibilities as vast as the universe, revealing how much we've yet to learn. Think about the implications. If extremophiles on Earth can survive boiling vents or frozen tundras, why not silicon-based creatures floating in Titan's methane lakes? If the WOW signal was a cosmic hello, why did it never repeat? And if governments have recovered exotic materials as whistleblowers claim, what might they be hiding? These aren't just puzzles for astronomers, they're challenges to our very understanding of reality. The Fermi Paradox alone stretches our imagination, forcing us to confront whether we're pioneers in a newborn universe or latecomers to a galactic party that's already ended. Your perspective matters in this grand debate. Maybe you're convinced von Neumann probes are already drifting through our solar system, or perhaps you think interdimensional beings walk among us unseen. Whatever your theory, the comments below are your launch pad. Share your wildest ideas, your favorite evidence, or the question that keeps you up at night. After all, the search for alien life isn't just about scientists in lab coats. It's about all of us gazing at the same stars, wondering who or what might be gazing back. Here's the beautiful truth. We're living in an era where the next groundbreaking discovery could be moments away. The James Webb Telescope is unraveling the atmospheres of distant worlds. AI is sifting through cosmic static for patterns no human could spot. And for the first time in history, governments are taking UFO sightings seriously. The pieces are falling into place, and humanity stands on the brink of revelations that could redefine our place in the cosmos. So stay curious, keep looking up. Because whether the answers come tomorrow or 1,000 years from now, one thing's certain: the universe is far stranger, far more wondrous than we've ever dared to dream. And the greatest adventure, it's just beginning.